Hi everyone. In this given problem statement, we have to implement tire or a prefix tree. A tire, pronounced as trie or a prefix tree, is a tree data structure used for efficient storage and retrieval of keys in a dataset of strings. There are various applications of this data structure, such as autocomplete or spell checker. So basically, right, we have to insert all the words into a trie node. There would be a Boolean search whether to check whether that word is present or not. It is going to return true if the string word is in the trie, or it can also check whether a particular word starts with a prefix value. We can do it using a linear one, but it is means in using arrays and list, and it is going to have a very bad time complexity, and it is going to be very difficult for us to implement. Because let's say, right, I want to search, let's say, app. Okay, I have to go, let's say here only there are two words, right? But there could be a situation, there could be 100 of words. Then I have to search app in, let's say, 100 individual unless we find it. And that time complexity will be very, very bad. We have to solve this in a linear time solution. So what is the way? There is something called try. So I can write it in Python. So it is called class try node. I can do if this is the initialization self. It is going to have a value which is known as self dot children, which is going to be an empty dictionary for now. And then it could also have self dot end of words, which is going to be false. Now let me implement try node. So initially, right, it would be an empty try. So we are going to insert the apple value. So you insert a at the top node. Then we are going to insert p, p, l, e. And here, because it's an end of word, we can also, in this try, right, we can basically say end of word to be true. We inserted the one. Now I have to search apple. So if I'm going to search, right, so I found the first one, a, then I will search p, p, l, e, and when I got the e, right, I am going to check whether that value is true, because all of these value would be false. Then I have to doing a simple search. So when I'm doing a simple search app, so I'm able to find it and it works fine. Now it starts with, again, if I have to insert a value called app, so it's already been inserted, so no need to do it. Let's say I have to add a word called ANT. So it is going to be A is already present, so I don't have to do anything. Here, from here, I can add this value and T would be the end of the word. It can, I say, true. Let's say AN. So let's say ANARCH. So N is already present, right? So I can add ARCH and let's say just true. So you're able to see, understand, right, how it is working. It is just finding that word in a linear time. So let's say if I got some value, right, and I have to search it up. So I don't have to search on individual value. So if I, let's say I have to search AXE. So I got A. Did I find X in this tree? There is no value called X in this one, right? So I can return true. Similarly, right, if I had to find APP. And this is a word, right? So I got APP. But P is not, it is not the end of the word. So I am going to return false, because if I have to find a word, right, then I have to match whether it is the end of the word or not. So in this way, it is going to work. Now let me jump to the Python solution where we can write and understand how can we implement a trie or a prefix tree in Python. The first thing we need to do, right, we need to implement our trie node. So class node, and here it's going to have a init function. Self, it's like a constructor, so I can say self dot children and self dot end of word to be false. Now once I've done that, right, I can say self dot root equal to try node. The value got initialized. Now I have to insert a value. So the first thing I'm going to do, right, cur equal to self dot root, and I can say for C in word if C not in cur dot children. In that case, what I can do, cur dot children of C equal to try node, and I can say cur equal to cur dot children of C. And once all is been added, right, we also have to add the end of the word value to be true. So it would be cur dot end of word equal to true. Similarly, when I'm searching for a value, right, I can again say cur equal to self dot root for C in cur dot children if no for C in word if C not in cur dot children. So that basically means that word is not present, right? I can return false cur equal to children of C, and I can basically return cur dot end of word. So basically, right, if it's not the end of the word, right, it is going to return false. If it's the end of the word, then we can return true. That's the idea. And starts with, it would be same. So cur equal to self dot root for C in prefix if C not in cur dot children. In that case, I can return false cur equal to cur dot children C. And because we are not finding a word, right, we are just finding the prefix, right? So no need to return the end of the word. We can simply return true out here, because if that word was not present, right, it would have anyway returned false by that time. So let me run the code. Unless there are some spelling errors, it should work fine. As you could see, it got accepted. Let me try to remove spaces so that you can also see it in a line. So it looks fine. Now let me submit the code, and as you could see, it ran successfully, and the time complexity of it, right, is going to be big O of n, because we are searching the value in linear time. And as you could see, it's running at 94.33%, so which is pretty efficient for this type of solution. That's all for this video. See you in the next one.